Okay, what we're going to start out with today is the graph of the tangent function. So if I had to graph f of x equals tangent x, okay, then I need to know what exactly is that function going to look like. Well, let's start by taking a look at the definition of the tangent, which we know is sine divided by cosine. Okay. So that's another way to write the tangent of x. And like we talked about in our warm-up here, if we have a fractional equation here, and it has some bottom that can possibly equal 0, then we should expect that we either have asymptotes or holes. Okay? So in the case of tangent, if you look at cosine x on the bottom, okay, we should expect that when we set out to draw a graph of this thing, okay, that we have some asymptotes. And that's exactly what we do have, because we know that cosine can certainly equal 0. Okay, and so our job here, first of all, is to figure out when does it equal 0. So I'm going to draw my unit circle over here. Okay. And I'm going to think about my cosine function. When does the cosine equal 0? Well, if we're at this point right here, that's the point 1, 0. Does the cosine equal 0 there? Every point on the unit circle is of the form cosine sine. So is the cosine 0 here at this point? No. That means that at 0, okay, we don't have an asymptote. Okay, so all I'm concerned about right now are just the asymptotes. Okay, what about at this point right here at pi over 2? At pi over 2, okay, the coordinates are 0, 1, which makes the cosine 0. And if the cosine is 0, that makes a problem with the tangent. Okay, so I'm going to make my 4 tick marks here. Okay, and I'm going to do it just like I did with sine and cosine. And what I'm going to do is I'm going to put in the asymptotes where they belong. Okay. So there's going to be an asymptote at pi over 2. Okay, going around the circle, at this point we're at negative 1, 0. At this point we're at 0, negative 1. And so at this point we have another one where the cosine is going to equal 0, which would be 3 pi over 2. So we're going to have an asymptote at 3 pi over 2. Okay. And of course, if we think about it, if we continue to go around the circle, when we get over here to 4 pi over 2 back to 5 pi over 2, aren't we going to have yet another asymptote? And then when we get down here to 6, 7 pi over 2, aren't we going to have yet another one? Matter of fact, how many asymptotes are there going to be for this tangent function? Well, how many times can we go around the circle if we want to? An infinite amount of time. So how many asymptotes does the tangent have? An infinite amount of asymptotes. Now, I'm also going to talk about this going backwards. If I'm at negative pi over 2, the cosine is going to be 0, which makes the tangent undefined. Okay, so we're going to have an asymptote here at negative pi over 2. And of course, there's negative pi, negative 3 pi over 2, negative 2 pi. Okay. All right. So that's going to be our general setup, and I'm going to tell you right now, as we graph these functions that we're going to study today, okay, the very first thing that you want to do every single time, whether we're dealing with tangent, cotangent, secant, or cosecant, is draw the asymptotes where they belong. Okay. So remember when we did sine and cosine, especially when there was variations, when there was transformations involved, okay, I gave you a kind of a specific order to do it in so that you can get it right the easiest way. Okay, this is going to be the easiest way to deal with these 4, tangent, cotangent, secant, cosecant. Alright, so we're going to establish what the asymptotes are. Okay, at this point, what we're going to do then is look at and see what's going on between the asymptotes. So the next thing we're going to tackle is where are the zeros? Okay, where are the zeros? So the zeros of tangent, kind of like we talked about in the warm-up, the zeros are going to be when the top equals 0. So where does the sine equal 0? Sine equals 0 at 0, pi, 2 pi, 3 pi, 4 pi, going backwards, negative pi, negative 2 pi, and so on. Okay, we're going to have zeros at all these points in between. So I'm going to make some big points here for emphasis here. So we're going to have zeros at all these points that I just marked. Fair enough? So we found the asymptotes, we found the zeros, and then from there we need to figure out what does the general shape of this tangent function look like between the asymptotes besides at the particular 0. Okay, so I'm going to take the values here between 0 and pi over 2. We're going to plot a few points here. And we're not going to do this for each of these different parts because it's a cyclical function just like the others, which means that whatever is happening between these two asymptotes is going to be the same thing that's happening between these two asymptotes, and so on. We're just going to repeat the same shape. But looking at our values here, let's start at pi over 6. Okay, at pi over 6, I would have on top 1/2, on the bottom radical 3 over 2 for tangent. So that would be radical 3 over 3. Okay. At pi over 4, I would have radical 2 over 2 over radical 2 over 2, which would be 1. And then at pi over 3, I would have radical 3 over 2 over 1/2. Okay. So sine over cosine, which would be radical 3. So those are 3 more values for a tangent that we could plot here between 0 and pi over 2. Okay, and as it turns out, of course, if this is our 1 scale right here on the y-axis, okay, pi over 401 is going to be right there. Okay, pi over 6, radical 3 over 3 is going to be about right here. And then pi over 3, radical 3 is going to be about right here, 1.7. Okay. Now, I want you to think about what's going to happen as we get closer to pi over 2 here. Okay, as we get closer to pi over 2, okay, the sine values are getting bigger, the cosine values are getting smaller. True? So the fractions, and just like I showed here, when we're close to 0, the cosine values are big, sine values are small. As we get closer to pi over 2, the opposite. The sine values are big, cosine values are small. So what's going to happen here is as we get infinitely close to pi over 2 here, and the values of the tangent are going to get bigger. And hence, it's going to behave just like a normal asymptote, and we're going to have the curve look like that. Okay. Similarly, going the other way, if I go the opposite direction and I plot those same points, okay, but they're opposites, remember, because tangent's odd, we're going to get the negatives of those same values. So we're going to get 1 here, and we're going to get this general shape in that area. Okay. So that right there is 1 cycle of the tangent function. Okay. Now, as I mentioned a minute ago, the tangent's a periodic function just like sine and cosine. So what's going to go on in this particular area? Same. So I would plot these 1 points right here and then draw the same picture. So how many cycles do I need to draw? Okay. Well, it depends on what they ask. If I get a couple of them here, okay, I'm just going to stop with 3 at this point. But ultimately, these 3 curves, that is the tangent function. Okay, it's part of it, obviously, because it goes on forever in both directions. Okay, but that's what the tangent function looks like. Okay. Now, if you take your calculator and go ahead and put in tangent x, make sure you're in radian mode, which I'm currently in radian mode, that's just good. Put in tangent x into my y equals. On my window, I'm going to make it go from negative 2 pi, and you can go ahead and type in 2 pi, it'll just change it to a decimal, to 2 pi. And then I'm going to make my tick marks go by pi over 2. And then in my y direction, I'm going to go negative 5 to 5. And then I'm going to go ahead and hit enter and see what my picture looks like. Oops, I'm going to just have a stat plot on, turn that off. And we see that the picture that we get looks exactly like what we thought, doesn't it? A couple of comments I want to make too about the signs of the tangent here. You notice that between 0 and pi over 2, the tangent is positive. It's above the x-axis. Okay? Because what does 0 to pi over 2 represent in the unit circle? That's the first quadrant, isn't it, of the unit circle? And we know tangent's positive in the first quadrant. When we're in the second quadrant, which is between pi over 2 and pi, notice what are the values of the tangent like? They're what? They're negative. So that's what tangent's like in the second quadrant. And between pi over 2 and 3 pi over 2, which is the third quadrant, what are my values like? Positive. And what do we know about tangent in the third? It's a negative divided by negative, so we better get a positive. Fourth quadrant, we'd be back down here in the negative part. Okay, this also represents the fourth quadrant right here because we're going from 0 to negative 2 pi in the clockwise direction. So therefore, that part had better be in the negative area also. Okay. One other thing I want to point out here too is how about the period here? What's the period of the tangent function? How far am I going from left to right before I start over with the next part? Remember, sine and cosine, the period was 2 pi, wasn't it? So how far is it from negative pi over 2 to pi over 2? It's pi. Okay. So unlike the sine and cosine, the period of the tangent function is actually pi. Every pi, okay, we start over again with a new picture. Fair enough? Okay. All right. And as you can imagine, we're not going to work on this today, but if I had something of the form tangent of 4x, if you will, okay, that's going to mean our period for that is going to be pi over 4, absolute value of 4, if you will. It's going to be the same formula for sine and cosine, except for instead of 2 pi on the top, it's going to be pi on the top for tangent. Fair enough? Okay. Questions so far on the tangent function?